So what's on the inside of Saturn? Well, what's on the inside of Jupiter? You basically got the same thing. Sort of core, rocky ice core or something like that. Metallic hydrogen. Now if you look and you see the difference there, the mantle is a little bit thinner than the one on Jupiter. Actually, a lot thinner. And then the atmosphere or crust, if you will, is a little bit thicker in comparison. Now, granted, Saturn is a lot smaller than Jupiter, so all this is going to be smaller, but proportionately you can compare them. Saturn has a strong magnetic field, not quite as strong as Jupiter's, but it is strong. It's actually 1/20th of Jupiter's. We think it does have that metallic hydrogen mantle, not quite as large as Jupiter's might be, but still there. And it's spinning pretty fast, Saturn, so spinning, metallic, liquid, magnetic field. Okay, so remember I talked about the helium being a lot less here than it was in Jupiter? This is why. So Saturn's a little bit hotter than we thought. It's giving off a little bit more heat than we actually predicted. And what we think is happening is the helium is condensing. It could be condensing to form liquid, could be condensing to form solid. Not entirely sure, like basically rain or snow, right? But if it's more on the snow, then the helium should be condensing and it would look like, now obviously it wouldn't be, but it would look like diamonds were falling from the sky. So think about that for a minute. They're basically saying that the less helium is causing for more heat because it's raining diamonds on Saturn. You seriously could take this to Hollywood and they would laugh at you. But it's raining diamonds. Now, granted, this is theoretically possible. There's no evidence to actually confirm this, but just the fact that it's totally cool and completely possible is mind-blowing. So I said the heat thing. Well, the cloud top is 97 degrees Kelvin. It's actually higher than we expected, and it gives off 3 times more energy than it receives. So it's giving off a lot more energy. So we think that rather than having the heat left over from formation, it's this heat from the condensation of helium into diamond rain that's causing the excess heat. Crazy. So helium forms a mist layer and the cool outer layers starts to rain. So this helium, remember, starts to rain diamonds, and the helium is basically taken out, right? So when it rains, what happens to the cloud? The cloud disappears, right? Eventually all the rain stops because the cloud's gone. So same sort of thing in Saturn, right? It's raining and all the diamonds are gone, so it's taken out of the atmosphere, and it sinks into what? Still not entirely sure, because like there's no crust or anything. So maybe it's a mantle? I don't know. It sinks, it compresses, heats up when things compress, so that's where the energy is coming from. So in the future, you're going to run out of helium, right? There's no evaporation, so you're just going to run out of helium. So it's going to stop raining, which means Saturn should cool, and Saturn should go down to about 74. Now, it was 97, right? So we're looking at about 20-some degrees difference here.